Here we describe methods for bringing the real world into the laboratory, how to prepare and present real objects and match two-dimensional images of the same items under tightly controlled viewing conditions. Current knowledge of human vision is derived from studies that have relied on stimuli in the form of computerized two-dimensional images. However, it's unclear whether images of objects trigger similar underlying cognitive and neural processes as do real-world solid objects.
Although working with real objects in experimental contexts presents numerous practical challenges, the approach will yield important new insights into the mechanisms that underlie naturalistic vision. Here we compare real objects and image vision in a decision-making context. However, the general approach can be extended to study other cognitive processes, such as perception, memory, or attention.
Begin by creating a circular wood base for the turntable that is 2 meters in diameter and has a round central core with 20 slots. Create 20 dividers and slide each divider into the central core of the turntable to form 20 cells. Place the core on top of a rotating cylinder, allowing for easy rotation. Create a vertical partition between the turntable and the participant, and place it 26 centimeters from the turntable, allowing room for an LCD computer monitor behind the partition. Construct an aperture in the partition and ensure the width of the aperture is adjustable so that in the final setup, the participant can see only one item on the turntable at a time. Next, place a sliding platform and the participant monitor between the turntable and the partition to allow for rapid transitions between display format conditions.